Here we have a problem where the golf ball is passing through a window of glass. The glass clearly is going to break and slow the ball down. So we see a change in momentum of the ball as it passes through the glass. I'm going to start by drawing a picture. I'm going to draw the golf ball. It's moving here to the right. We've got our glass, and then later we've got the golf ball continuing to move to the right as it passes through. We can identify the things given in the problem. They give you this 25 grams. Well, that would be the mass of the golf ball of 25 grams. Now, typically we want to go to SI units. Our standard would be kilograms. So I'm going to convert that to kilograms. If we divide by 1,000, we get 0.025 kilograms would be the mass of the ball. It's traveling here with an initial velocity, and then later it's going a little bit slower. All right, so we know the initial velocity of the ball. Let's say everything here is to the right. We'll call it positive. Now, in this case, we don't get a change in direction, so the signs aren't going to be an issue, but it's always a good habit to put the plus sign. Later, you have the ball with some new velocity. They tell us that there's an impulse, but they don't tell us what the final velocity of it is. However, they do tell you the amount of impulse. The impulse on the ball, we'll use the letter J for impulse, is 0.16 kilogram meter per second. And if you recall, we got a couple equations here. We know that impulse is equal to the change in momentum of an object. And change in momentum is just the change in object's momentum at the end minus the momentum at the beginning. But momentum, remember, is an equation P equals mv, right? So if we look at this, we can actually substitute here and find that J is the momentum at the end, which would be the mass of the ball times its final velocity, minus the momentum at the beginning. And so we can simplify that down. You get the mass of the ball and its change in velocity. It's another way to do that here. So you have all these different variations here. We just do a little algebra. You can reorient what we have here. And we know the amount of change in momentum, J, is 0.16. I'm going to put the units in here. I'll show you how they all work out. Kilogram meter per second. On the right side, we have our mass of 0.025 kilograms. And we have our two velocities. Our final velocity we don't know. And we'll subtract the initial velocity of 16.8 meters per second. Now we just need to do a little bit of algebra. Really now we're solving for V final. We're going to, I'll change my pen here. Let's divide both sides by the mass of 0.25 kilograms. 0.25 kilograms. Again, notice our units will cancel. We're now in meters per second on the left, and its only velocity is on the right. So as expected, we have only meters per second there. So I'm going to take the 0.16 and divide it by 0.025. I think I had a typo in my original work. I get 6.4 meters per second is what the change in velocity is. 16.8 meters per second. And now I'm going to add 16.8 meters per second to both sides. And I'm going to add 16.8 meters per second. And we get a final velocity. If I add 16.8, I get 23.2. 23.2 meters per second is what it's suggesting the final velocity would be. But that doesn't seem to pass the smell test, right? If the ball is going at 16.8 and passes through a window, well, how could it be going faster after passing through the window? All right, so this is where the importance of having a picture in your head so you can identify where there might be a mistake. So I think we got a problem here. Because the ball can't speed up having gone through the glass. And if I did a good job drawing my picture, I'd actually probably want to draw this arrow clearly shorter. So I'm expecting a final velocity of less than 16.8. So where did I go wrong? Well, here I think we have a sign issue. Where could there be a sign issue? Let's check everything. Velocity initial is to the right. I have a positive. V final minus V initial. Is v initial, it's to the right, so that's fine. So minus a positive. Now let's see, v final should also be positive. What is impulse though? Impulse is a push over a period of time. Well, there's a direction to the push. Which way does the glass push on the ball? I think there's our issue. We need a negative sign to indicate the leftward push that the glass would have on the ball. And when you get the negative in here, we'll start putting the negative here on the left side with our impulse. When you divide, you actually get negative 6.4 as the change in velocity, right? That glass is subtracting velocity. And when you take our negative 6.4 and you add the 16.8, you get 10.4 as our final velocity, which makes a little bit more sense. All right, and so we get a positive answer. I expect it to still be to the right, but it is indeed less than the 16.8, which is what I expect. That glass took away 6.4 meters per second of velocity from that golf ball to end up with a final velocity of 10.4. So a good example where we see an impulse acting on one object and changing its momentum. And again, the importance of getting our signs right. An impulse is a vector quantity. There is a direction to it. So it's important that we get the direction correct with that negative sign here. So hopefully it gives you a good little example here with impulse and the change of momentum of a single object.